Today, we're here to talk a little bit about big data, kind of a buzzword out there. You know, one of the things that we see a lot, I guess I wouldn't say a lot, but one of the offerings that we have is dealing with failed implementations and dealing with systems that have become unruly. I know we're dealing with one now where we're migrating from one sort of data environment that was using some outdated tools into something that was using some of the tools you just talked about. But you see a lot of things that fail in implementation. You see a lot of problems that come up with big data implementation. So what are the things you should avoid and make sure you're not doing when you're working in a big data environment?
Most of the time the problems that you're going to face have to do with the fact that you've outgrown the system that you're currently on. Not many people start from the very beginning with a massively scalable big data operation. They'll typically start with your standard type of database setup and then outgrow it. And so once you reach that point, there's a few things to consider when you're planning out your big data architecture. I guess one of the first things is to really put a lot of thought up front into the flow of the data. How does it get from source to destination, and how many different steps are going to be in between, and figure out how that fits into the products that you've chosen. Whether you're using Google Cloud Dataflow for ingesting the data, or BigQuery, or possibly Bigtable, depending on your query needs. Those are both Google Cloud platform big data storage engines. So just map out how your data gets from point A to final destination and how many steps are going to be in between. And kind of along that same note, one of the things that you can do to make your data ingesting and transforming process more debuggable, easier to manage, is going to be prefer small incremental changes as opposed to large changes. So when you design one of those steps in between point A and point B, make sure that you can break up the process into maybe smaller ones that do more specific transformations over the data. And the reason why that's a good approach is it makes it much easier to track down where a problem in that pipeline might be. And I guess lastly, one of the pitfalls is just managing your costs. The products that are out there for big data are great, but you definitely want to make sure you understand the pricing structure, because a poorly designed big data infrastructure built on top of AWS or Google Cloud can potentially be very costly. So whether check how do they charge when it comes to querying your data or storing your data. Can you optimize some of the queries to reduce the amount of data that's processed? A lot of times it's pay for what you use. So pay for every byte that gets processed during a query. And a lot of times you can optimize your queries to reduce the amount of bytes processed.
Great. And I'm assuming the same applies to the open source tools, except there the cost is really scaling to however many servers you need. So you still, even if you're not using an AWS or a Google or an Azure big data service, you still have to plan things out very carefully. Otherwise, you're looking at hundreds and hundreds of extra servers that you otherwise wouldn't need.
Exactly. In that case, you're not paying per byte processed, but the more efficient your queries are, the smaller number of servers you're going to need. So at the end of the day, those servers are going to cost you, from purchasing them to power costs for running them. And so you definitely still want to keep optimization in your mind in open source networks as well.